Hello and welcome to Embedded Internals. This is fourth episode of our series, the System Fundamental series. In this episode, we are going to understand what are integer overflows, what are different type of promotions and type conversions available. We will also see that overflow is not always an error. Sometimes it can be a wrap, sometimes it becomes undefined, and sometimes the compiler assumes that overflow never happened, why these occurs and how we can prevent it. First thing, computer have finite bit. When we say that computer have finite bit, we mean to say that it cannot represent the infinite numbers, right? Like we know that bit, which is the smallest representation of number inside the computer system, and 1 byte equal to 8 bits, and we have total of 255, and the range of available bit is 2 to the power 8, that is 256. That can be represented from 1 to 255, that is this will become the range, that is basically 0 to x to x 2 to the power 8 minus 1. This is the finite range of our finite bit. Once you exceed the available bits, something happens, which we termed as overflow. Let's take an example. When we say signed char, sign means when the sign bit is enabled. So it is signed char a is equal to -1. How the -1 will be represented? Mostly last value is 1 and then overflow will occur. It will simply all bit turn to 1. Similarly, when we will represent unsigned bit, unsigned char having the value b 255. 255 is represented by all 1. So we have seen that same bits have different interpretation. Storage is identical, but because of the different type, meaning has been changed, and type changes because of signed or unsigned character. We have a concept of overflow. When we exceed the available bits, overflow occurs. So something beyond the range means overflow. Let me show you the same example, unsigned char. We have unsigned char. Now what will happen when you try to write or increment this value? So ideally it should become 256. But let me show you the output of this first. This is a very simple program where we have declared a variable x as unsigned char and assigned the value 255 to it. And in the next statement, we have incremented the value by 1. So 255 plus 1, it should be 256. So let us see what is the output of the same. 0. So why the value is 0? Why not 255 plus 1? That is 256. What happened here? What is actually happening inside is the overflow. We have the maximum range from 0 to 255. And if we exceed this range, overflow will occur. So 255 plus 1. So ideally we are exceeding this range. That is the reason overflow is occurring. So what is happening when we will do 255 is represented like this. When you are going to add 1 to it, so when you are going to do the addition to it, it will simply become, we are representing only the 8 bit, that is 0, and this is 2 to the power 8. 2 to the power 8, 256. And because of overflow, this last bit get discarded. Only 8 bit representation we are getting, and all the 8 bit are 0. So we are getting 0 as answer. This is the case of overflow, when last bit get discarded. Okay. This is also termed as wrap around. So now this is the case when we are doing operation on unsigned character. What will happen if we do addition on some signed character? We know that the range of signed bit is 127 to 128, right? Let us take an example where we have taken excess. When you will increment 1 to it, what will going to happen? We can say, because the range is 2 to the power -1 to this, and it is an signed signed overflow, we can say that we will get the value in the negative range of this. This can be the accepted value when we are going to the see the range. But in C signed integer overflow, sometime range in undefined behavior. Sometime it is not overflow, not wrap around, simply undefined. Why undefined? Compiler may wrap, compiler may sometime optimize differently, remove code, or produce unexpected results. Sometimes we get this result as well. Integer promotions. Uh, this happens when sometime lower data type get promoted into the higher data type range and operations got performed. When we do the addition of this, what result we will get? 200. Did addition happens in char or it will happen in integer? It usually happens in integer. So how the char get converted in integer and we get the result as 200. So the actual behavior what is happening inside is char is a small data type. It get promoted by the compiler into the higher data type range, that is integer, and then the arithmetic operation got performed, like in this case addition, and we get the result 200. Sometimes the result may be surprising because of this promotion mechanism. So when we are declaring any data type or doing the arithmetic operation, we should be very careful that internally promotion should not happen. Forty-four. So surprising results. Why 44? Any guess? 50 value in A and B. The character is converted in inside as int. So this will become int of A plus integer int of B. So compiler is inserting this promotion. Like in the earlier example where we have seen the overflow, uh, let us see what will happen if the promotion is allowed. Let us take an unsigned char and the value is 255 maximum range. Let's print the value A plus 1. Earlier we have seen that the integer value get wrapped around and we get the value 0. But in this case, when we have defined the variable as unsigned char, we actually get 256. Why? So in this case, 255, which is a character range, got promoted to integer. So integer is 255 plus 1, 256, and overflow did not occur. Because of the promotion, we are saved from the overflow. What answer you are expecting? A, that is minus 1, is less than B, that is 1. Minus 1 is less than B, less than 1. So let me compile it and see what is the answer, and if that is the answer, why? Answer is true. Let me change the data type from char to int. Now let us see what is the answer. False. Why false this time? Isn't minus 1 is less than B? What this integer has actually done? Minus 1, which is unsigned. Sorry, minus 1 is signed, which is promoted to unsigned, and the value become 4294967295. When the comparison is happening with this, so automatically this value become false, what we are getting as an output. Because of unsigned conversion, we are getting this result. Because of unsigned conversion, value become false. So for overflow detection, we have a safe approach where we usually first check if the overflow is occurring or not. Like we have limits.h header file in which the uh, useful constants are there, like int max, int minimum, uint max, and we usually check our value, compare our value using those macros, like int max, int minimum, min. Similar way, all the characters useful constants has been defined inside useful constants defined in limits.h. We first compare from these constant, and then we proceed as for the safety precaution. If x is greater than int max minus y, any parameter, then overflow risk, don't move forward. So we always have some check like this, comparing our variable from limits.h maximum range or minimum range. We some have one compiler warning flag slash underscore wall or underscore extra. When we are compiling our code, we can enable those flags, compiler flags, to detect overflow. Arithmetic pipeline. Arithmetic pipeline, something which sometime the programmer miss. That is sometimes it is the compiler defined behavior. So we should be very careful when we are performing it. So we can say the variable are loaded into the memory. Promotion may happen, data type promotion. We can compute the value. Conversion may happen, then convert the value. And then we are going to store the value into the memory. So arithmetic is not a single step process. It is multi-step. Load the value, promote, compute, convert, and store. Arithmetic in C happens on types, not on mathematical number, because sometime overflow risk or sometime type conversions all are happening on the data type, not on the mathematical number. Now that we understand how number behaves, next we will going to study see how C actually perform the computation. So in this episode we have seen what are integer promotions, integer range, overflow, and signed and unsigned bit. Basically, uh, we know that computer have finite bit, and we have a range of integer range. Similarly, we have the all data type ranges available. Every data type can be into the signed, signed int, signed char, signed float, or everything is in signed value or unsigned value, have their defined range using the formula this for the signed and unsigned. Based on the data type, we sometime there is a chance of overflow when we when the range of memory get exceeded. Like inside the character unsigned char, we have 8 bit of memory. 1 byte means 8 bits. When this 1 byte got exceed, the last character may get discarded, and we get the unexpected value, and this is termed as overflow. That similar behavior can occur in the signed, unsigned parameter of any data type, unsigned char, integer, everything. When the range overflows, we can get the undefined behavior as the byte, last bytes got discarded by the compiler. So we should be very careful while we are defining the values. Then we have integer promotions. Similar to integer promotion, we have all the data type promotion, where the lower data type is promoted into the higher data type for any arithmetic operations, and this can change the output, expected output a user is suspecting, and this is done by the compiler automatically. So a programmer need to be very careful when they are declaring doing any arithmetic operation on any data type. We have lots of useful constants defined in limits.h, where maximum and minimum of all data type has been defined. First we should compare our value from those constant to detect the risk of overflow, and while compiling we should use uh, wall and extra compiler flags to detect if there is any overflow or there is any integer promotion has occurred, because overflow and promotion, integer promotion or any data type promotion can change the result we are expecting. So we can say that arithmetics operation inside the machine is not a single step procedure, but it is like memory is loaded, then it there may be chance of promotions, then the computation is happening, finally we are converting and storing the value. So it is a multi-step process, and arithmetic in C happens on date types, not always, not on a mathematical number. So this conversions are promotions are all usually happening in the uh, data types and conversion as well. So we should be very careful when we are doing any kind of arithmetic inside the operating system. This is all in the integer promotion, overflow and conversion this episode. Next episode we are going to see arithmetic operators through CPU thinking, where we are going to evaluate uh, instructions, how the instructions are executed by the CPU. Stay tuned for same. Thank you.